In this video presentation, what we want to look at is complex fractions. We have 2/3 plus 1 and 2/7 all over 3 minus 2 and 2/7. So what we're going to do is just to convert all our mixed numbers to improper fractions. So we're going to rewrite this. We're going to convert this to 7 times 1 is 7 plus 2. It's going to give us 9 over 7 all over 3. I could say 3 over 1. And this part, I'm going to convert this to an improper fraction. So we're going to have 7 2s 14 plus 2. So it's going to be minus 16 over 7. I'm going to refer to this part as my top part. And this part I'm going to refer to as the bottom part. So the idea is that I'm going to work out the top part, and then I'm going to divide it by whatever I get from the bottom. That's the idea. So let us start off by looking at the top part. So the top part is basically 2/3 plus 9/7. And then we could use 21 here as the lowest common multiple of 3 and 7. So we're going to divide 3 into 21. That's going to give us 7. 7 times 2 is going to give us 14. 7 into 21 is 3. 3 times 9 is going to give us 27. So what we're about to do now is just to add. So when we add the 14 plus the 27, we're going to get 41 over 21. Right? So 41 over 21, and this part is for the top. Let us see what we have for the bottom. So for the bottom, I have 3 over 1 minus 16 over 7. My LCM is 7. 1 into 7, that's going to go 7 times 3, 21. 7 into itself is 1 time. 1 times 16 is 16. So 21 minus 16 will give me 5 over 7. And this part was for the bottom part. So finally, what we're going to have is the top divided by the bottom. So the top part is 41 over 21. And I'm going to divide by using this division symbol, 5/7. When we divide, we write back the first fraction. We change our division to multiplication, and we're going to reciprocate the last fraction. At this time, I do realize that I could cancel 7 into itself, 1, and 7 into 21, 3. So 41 times 1 is going to give me 41 over 3 times 5 is going to give me 15. So this is my answer. We could represent this as a mixed number. 15 into 41 goes 2 times, and remainder 11 over 15. So any one of these answers would be acceptable and good. Let's take a look at the next problem. All right, so in this other example, we have 1 and 2/3 plus 2 and 1/8 divided by 3/4. One of the first things we're going to do is just to convert all our mixed number to improper fraction. So for this one, it's going to be 3 times 1 plus 2, and that's going to give me 5 over 3, plus this one here, which is 8 times 2, which is 16 plus 1. That's going to give me 17 over 8, and I'm going to divide this by 3/4. Remember, whenever we're working in mathematics, the order of operation does work. So we're going to have to zoom in on this part first. We're going to have to isolate that and deal with that first. So basically, I'm not going to be using this yet. So I'm going to be working on the division aspect. But when we divide, we definitely know that we change that division to multiplication and reciprocate the fraction that comes after it. Within this parentheses that I have, I can divide 4 into itself 1, 4 into 8, 2. So what I'm really left with is this. Let's write back over 5 over 3. 17 times 1 is going to give me 17. 2 times 3 is going to give me 6. So what comes from the division was actually this, right? And then we're going to be adding it to this. So now let's look. The common multiple is a 6, as you could see. So 3 into the 6 is going to go 2 times 5 is 10. 6 into itself is 1 times 17 is 17. We add this, we're going to get 27 over 6, right? So this is a 27 over 6. And if we reduce this by dividing through by 3, so 3 into 27, that's 9. 3 into 6, that's 2. So my final response is 9 over 2, which is the same thing as 4.5. So there it is. We could submit this or that for this one. Let's take a look at the third and last. A parenthesis. We have a bracket, and inside that bracket we have 2 1/3 minus 1 5/6. And all of that result must be divided by 1 1/3. So this is a little different case from the other one, because this one we actually have a bracket. So we're going to have to find out what is in the bracket first. But before we do that, let us convert everything to a improper fraction. 3 times 2, 6 plus 1, that is 7 over 3. Subtract 616 plus 5, 11 over 6. And then we're dividing this by 313 plus 1, and that is 4 over 3. All right. So within the bracket, what we actually have is two different denominators. We're going to use the LCM, which is 6. 3 into the 6 is going to go 2 times. So 2 times 7, this is giving me 14 here. 6 into itself is 1 time. So 1 times 11 is 11. We're subtracting, right? So we could write back this. So what comes from this is actually 3, 6, right? And we're dividing this by 4/3. All right, so 3, 6. Remember that we really don't divide, we multiply, reciprocate. So we could cancel 3 into itself 1, 3 into 6, 2. So what we're really left with here, as you can see, is at the top, 3 times 1 is 3. And 2 times 4 is 8. So we have 3/8 for this last one. All right, so there you go. We just looked at complex fractions. See you next time.